Hello students, I am explaining chapter number 1 Matter in our surrounding for class 9 science. Already I have completed the whole chapter explanation and I have uploaded all the videos on my channel. Now in this video I am going to solve Intex 3 that is present on page number 9. What is Intex? Intex is nothing but the questions which are present inside the chapter. So I am going to solve all the questions which are present inside the chapter. First two intakes already I have completed. I have uploaded the video. Now I am going to solve the third index which is present on page number 9. So let's start with the first question of this index. So in text 3, page number 9, first question, convert the following temperature to Celsius scale. So here we have two temperature A and B. Both the temperatures are in Kelvin. So we have two measuring scales for temperature. One is called degree Celsius and one is in Kelvin. Degree Celsius, it is a common unit which is used to measure the temperature, and Kelvin, it is the standard unit or SI unit which is used to measure the temperature. So here the temperature is given in Kelvin, we have to convert it into degree Celsius. Remember students, we can convert the temperature from Kelvin to degree Celsius or from degree Celsius to Kelvin. Just we have to remember the formula or the trick which we use to convert this. So let's start the question. So here we have temperature in Kelvin, we will convert it into degree Celsius or Celsius scale. So answer, to convert temperature from Kelvin to Celsius or degree Celsius, we use the formula, and the formula is degree Celsius is equals to temperature in Kelvin minus 273. Remember this formula. So whatever temperature is given in Kelvin, that we have to take and we have to subtract the 273 value. When you subtract that value, whatever the remaining answer you will get, value you will get, that will be written in degree Celsius. So see the first one. The first one is given 300 Kelvin. So use the formula, degree Celsius is equals to temperature in Kelvin is how much? 300 minus 273. So we will get 27 as the answer and write the 27 degrees Celsius. So you know 300 minus 273 we have to do. So here 10 minus 3 will be 7. Here number 1 will be carrying. Then 10 minus 8 will be 2. 1 will carry. And here 3 minus 3 will be 0. So answer we are getting 27. So write here 27 and now it is in degree Celsius. Second one is 573 Kelvin. So take again degree Celsius is equals to the temperature is 573 minus 273. Subtract, we will get 300 as the answer. Write that 300 in degree Celsius. So let me do it here. 500 minus 273 we have to do. Again 10 minus 3 will be 7. Carry 1. Then here what we are sorry, I have to take 573. I made a mistake. Let me clear it. So the given temperature is 573. So I'll write 573. By mistake I wrote 500. So 573 minus 273 will do it. Then 3 minus 3 will be 0. 7 minus 7 will be 0. 5 minus 2 will be 3. So the answer is 300. So therefore write down 300 and then write degree Celsius. So this is the answer for second one and this is the answer for first one. So remember, whenever you want to convert Kelvin to degree Celsius, you have to subtract 273, and whenever you want to convert degree Celsius to Kelvin, remember degree Celsius to Kelvin, you have to add 273. You have to add addition. You have to do the addition of 273. So this was the explanation of question number 1. Now we'll see the next question. Question number 2. What is the physical state of water at? So the temperature is given. Here it is 250 degrees Celsius and this is 100 degrees Celsius. So here two temperatures have been given. A is 250 degrees Celsius and B is 100 degrees Celsius. At this temperature we have to tell the physical state of water. So what are the physical states of water? We have three physical states. Let me write it here. Water. Here I'll write physical state. So whenever it will be solid, it is called ice. In liquid, it is called water. And in gases, it is called vapor or steam. So these are the physical states. Now at this temperature, we have to tell water will be in which physical state. Answer, to determine the physical state of water, remember. So what you have to remember? First, freezing point. Second, boiling point. So what is the freezing point of water? It is 0 degrees Celsius. Freeze means here liquid convert to solid. Liquid convert to solid and this process is called as freeze. Remember, freeze. Then boiling point means what? It is the temperature where water boils, and here liquid will convert to vapors or gases. So this is called as boiling. So the freezing point is 0 degree Celsius and boiling point is 100 degree Celsius. Remember these two things for this question. Now first, A, 250 degree Celsius temperature is given. So at 250 degree Celsius, water is above its boiling point. So it exists as a gas. It is nothing but steam or water vapor. So when the temperature reaches 100 degrees Celsius, water starts boiling. Remember, water starts boiling and it converts into vapors or steam. And now the temperature given is 250. 250 degrees Celsius means all water has been converted into steam, that is gas. And therefore we can write the state of the water is gaseous. Second one is 100 degrees Celsius. As just now I told, 100 is the boiling point of water. So once the temperature is 100 degrees Celsius, water started boiling. Water started converting into gaseous. So still there is some amount of water which is in liquid state and some amount of water will be converting into gaseous state. And that's why at 100 degrees Celsius, we can see both the physical state. Therefore, at 100 degrees Celsius, water is at its boiling point. So both liquid and gas states can exist together, that is water and steam. Remember this, when we take water in a beaker and started heating it in thermometer, when it reaches 100 degrees Celsius, the water started converting into gaseous state or vapor state. So here we have water vapors here and even the water is there in liquid state. So we can see both the state at 100 degrees Celsius. But in the first question it was 250 degrees Celsius. It is very high temperature. At 250 degrees Celsius all water will get converted into gases. And therefore in the first question we wrote all water will be present in gaseous state. But in the second question answer is water will be present in both liquid and gaseous state. So this was the answer for question number 2. Now we'll see question number 3. Question number 3. For any substance, why does the temperature remains constant during change of state? Very simple. Whenever the change of state takes place, solid to liquid, liquid to gas, the temperature in the thermometer remains constant. It will not change. For example, if the temperature has reached 0 degrees Celsius, then it is changing from wait a minute, liquid to solid, means it is getting freeze. And when this freezing process starts, the temperature remains at 0 degrees Celsius. It will not change till all liquid convert into solid. Once all conversion is completed, then the temperature changes. So till this conversion, it remains constant. When the temperature in the thermometer rises to 100 degrees Celsius, liquid started boiling and it convert into gases. But till this all liquid convert into gases, temperature in the thermometer remains constant, that is 100 degrees Celsius. Once all liquid convert into gases, then if you continue heating, temperature started rising into the thermometer. So the question is why it remains constant during the change of state. See the answer. During change of state, like melting or boiling, the temperature remains constant because heat supplied is used to change the state, not to increase the temperature. So imagine if this is a beaker and here I have taken water. So I'll write it here, water. And this is the burner which we are using to boil the water. And this is the thermometer into this solution. And here I have taken one glass rod for mixing, for stirring. And here I'll write it thermometer. Now, when we started heating, the reading in this thermometer started increasing. That is 10, 20, 30 like this. When it reached 100 degrees Celsius into the thermometer, the water in the beaker started boiling. This water started boiling. Boiling means water is converted slowly into gases. So one by one, solid, this liquid particles, water particles are converting into gaseous state. Now, when this conversion is started, the temperature in the thermometer remains constant, that is 100 degrees Celsius. We are heating continuously, we are supplying heat, but still the temperature remains constant because whatever heat we are supplying, that heat is used by this water to convert the state from liquid to gaseous. It is not used to increase the temperature in the thermometer. It is used to convert the change or the state from water to gases. And this heat is not shown in the thermometer. It will be hidden inside these water molecules. And that's why it is called as hidden heat or also called as latent heat. The particles of substance use the energy to overcome the forces of attraction between them. So these water particles all have attraction, forces of attraction between them. These forces we have to break, then only water can convert into gases. And to break those forces, the heat will be used. And that's why this heat we cannot see into the thermometer. So this here, as a result, the substances changes from solid to liquid or liquid to gases without a rise in temperature. So this is the answer for question number 3. I hope you will understand the answer. Now I'll move with next question. Question number 4. Suggest a method to liquefy atmospheric gases. Liquefy means converting gases into liquids. This process is called as liquefaction. So we have to suggest one method to convert atmospheric gases into liquids. So the answer is by increasing pressure or by decreasing temperature. So we know gases, there will be much amount of space in between the particles if you imagine gases. And what about liquids? For liquids, the space between the particles will be less. So what we have to do? Just we have to decrease the space in these particles in case of gases. So to decrease the space, we are going to take a piston and we have to give the pressure on this gas. When we increase the pressure on the gas, these all particles will try to become close to each other. And when they come close to each other, temperature decreases and they will convert into a liquid state like this. So therefore, the method suggested is increasing pressure with the help of piston and decreasing temperature. So see here, atmospheric gases can be liquefied by compressing them. For compress means what? You are increasing the pressure, that is high pressure, and cooling them, that is low temperature, decrease the temperature. Under these conditions, gases changes into liquids. So this is the answer for question number 4. So here I have completed the answers for the questions which are present on page number 9, that is nothing but Intex 3. So make the note of this all the answers in your notebook which can help you to prepare for your class test or final exam. I hope you will understand the explanation of each and every question. And if you like my videos, share my videos with your friends. And if you're getting a little bit also help from these all the videos, then please consider subscribing my channel. Thank you so much.